This is a Thorium Energy Alliance Technology Talk from the inaugural Future of Energy Conference, October 2009. To find out more about Thorium Energy, please visit thoriumenergyalliance.com. This talk is from Colonel Paul Roege, United States Army Capabilities Integration Center, whose topic is Nuclear Energy. Should the Department of Defense lead or follow?
So why not nuclear? Well, this probably isn't any surprise to most of you. Certainly public opinion has been against nuclear for the last few decades. That seems to be changing a little bit, but I hear very frequently the opinion that you just can't sell nuclear. Usually what I hear is, I don't think it's so bad, but nobody else will buy it. It's everybody else that's going to be against it. Proliferation concerns we started to talk about this morning and had to cut that off. So clearly there are plenty of people concerned about that. Investment challenges, I think, are key, both for the military and for the civilian world. And we just had a little bit of a chat about that during a break. But one of the big challenges for new reactor designs is that you're talking about technology that isn't as mature in the market. We have light water reactors out there operating all over the U.S. People have been buying them, building them. You've got the fuel supply chain built in. You've got the training. Now, if you want to build some kind of an advanced reactor, the next generation, there are some things that need to be developed. The time to market and the perceived risk of those things might be a little bit higher. The U.S. economy doesn't seem to be really supporting those things that are long-term investments, maybe higher investment, higher risk. So one of the opportunities the military has is to go ahead and take those risks and make those investments, because our decision process isn't as driven by short-term amortization payback on our investment. We have some other considerations. Environmental concerns, that's kind of an interesting topic, because the reason people are starting to change their attitude about nuclear is in large part because of environmental concerns. We see mountaintops being leveled in West Virginia. We see polar bears stranded on the icebergs. And so there's some growing recognition of the environmental impacts of non-nuclear energy sources. So what we may do over the next 6-8 months within DoD is to conduct some kind of a study that would look at nuclear energy and look at Army or DoD energy needs and see how do those mesh up. And the reason that hasn't happened, I think, is because it's a tough question. There's a lot of issues, a lot of pros, a lot of cons. It's quite a change from what we're doing today. And so you have to bring together a lot of people with different areas of expertise, different perspectives to try and get your arms around all that, and you have to take kind of a systematic approach. So it's not going to be a simple study, but I think we may have enough support today to actually start up something like that. This chart here is one of the things that I use to talk to some of the military leaders, though. They really don't understand until you put this table up that, yeah, you can have battery-powered vehicles. Of course, you have to charge them up somehow. But they don't really carry enough energy to do much. So you end up with a liquid fuel economy, and you jump up a couple orders of magnitude, and you have to drive around your vehicles with liquid fuel. Well, that is not energy dense enough, though, to provide the sort of sustainability that we need out there in Iraq, maybe, but in Afghanistan for certain. We can't afford to be driving around the countryside in Afghanistan delivering fuel from wherever. They don't even have a port that you can ship in the fuel and truck it. So then you take several other orders of magnitude, step up in energy density, and all of a sudden you've got this energy source that we've been using for decades and provides 20% of our energy domestically. French, of course, are way ahead of us. And so that's why we need to take a look at it. So we all know nuclear energy isn't one thing. There's a lot of variations from RTGs that we shoot off past Pluto into space that provide reliable power for a long, long time, to the big reactors that we have all over the country, operating safely and providing inexpensive power. We've got a lot of different reactor concepts, different coolants, moderators, fuels, all that sort of thing. So you can probably tailor something that's going to meet your needs with nuclear energy. There's a lot of options out there. Well, another application area would be transportable energy. We had that picture several slides ago of the operating base somewhere in Central Asia, Southwest Asia, Timbuktu. Actually, could be Africa. We're certainly starting to look at Africa from a military standpoint. You want to be able to take this energy source with you and move it when you move. So what do you need that to do? Well, it needs to not require a lot of resupply. The whole idea is you don't have to keep running the resupply convoys. It would be good if it's air transportable. A lot of the places that you would want to deploy this, for the same reasons that you don't want to keep running supply convoys, you don't really want to have to truck this in, or it may be very difficult to truck in a large, heavy vehicle. It's one thing to move a truck around, say, the East Coast or West Coast. It's quite another to be in some mountain pass in Afghanistan. It really limits the size of a package you can take in. Again, you need rugged, proliferation-resistant packages. You can have people coming in, shooting at you. Ultimately, you could have somebody overrun a site, and you don't want them to get their hands on something that they could use against you that wouldn't be easier to get some other way. And it needs to be safe and simple, because part of the idea was I don't have my soldiers out there running a supply chain. I have them fighting. Well, I don't want them running my nuclear reactor and syn fuel plant either. So it needs to be very simple, and it needs to be reliable so that we're not having to fix it, or we're not without the energy. And then, of course, there's installation power. I think civilians may not really have an awareness today of how much the military is now concerned about the power on military bases, even within the U.S. We have a number of bases just in the continental United States that perform critical missions. We have people flying UAVs in Iraq from an Air Force base in the U.S. We have people running sensor systems and collecting information and providing real-time information to people in theater from places in the U.S. And if somebody were to come in and do something to our power grid, or even if something, say, a natural disaster, were to affect the power grid and disrupt the energy supply to our CONUS bases, that could be a bad thing for national security. We could end up not being able to support the troops out in the field, maybe not be able to provide fire support during some kind of an operation, give them critical information, and it could be a problem for a long time. There are some predictions that you could have a power grid disruption that would take months or more to restore with the grid in its current condition. So there's a growing interest in building more robust capability in U.S. bases to provide for the energy needs. There's a lot of talk about wanting to be able to island your base and have it self-sustaining. So what are the efforts today? Well, of course, the Navy already has as many reactors as the civilian sector does. So it's not like DoD is not in the nuclear business. However, that's about all that we're doing. The Army has one reactor really that's still operating at all, and it's not a power reactor. It's doing some material testing. Other than that, it's all talk. What does it take to operate in this future environment, which is changing? That's going to be a first step. If we can understand how the Army needs to be able to sustain itself in these diverse parts of the world, doing things we never thought we'd have to do, surviving against asymmetric threats. You never know when the guy you thought was your buddy or has a contract with you is going to turn around and walk in with a suicide bomb. Then we can start to design systems to accommodate that. So then the next step would be some kind of a demonstration. So let's say we're going to do nuclear energy technologies as something in the future. We figure out in the study phase how that nuclear technology might fit in. Then we're going to do some kind of a pilot demonstration phase. And so even if you look all the way down, off to the right at an ultimate long-term vision for deployable reactors, you're probably going to have, as an intermediate stage, some kind of a reactor on a base. So you combine all of the reasons that you might build something like that. You build those all into the objectives that you're designing for, and you build a reactor on some U.S. base. And then you learn from that. And then finally, in the long term, you go out and you build this deployable reactor that you can take wherever you want, and it's going to be safe, it's going to be proliferation resistant, and then in the really long term, you use that to help the world to become safer and more sustainable and maybe less prone to fighting over energy. And instead of saying we're not going to play in the nuclear business and assuming that's going to keep the world safe, we take a step forward and we work on better ways to do nuclear energy, and we share that with everybody so that everybody can be proliferation resistant and safe instead of going the cheap way. So with that, any questions I can answer? Sorry.